Hello, and thank you for joining us today. My name is David Oliver, Product Manager with Fluke Networks. Today we're going to be discussing how you can troubleshoot and tackle voice over IP performance issues, how you can manage, monitor, and maintain your network to clearly and cleanly deliver those voice over IP services so that your organization is not impacted by those who are complaining about poor performance with call quality. Today we're going to be talking about some of those key factors that can affect voice over IP, such as audio codecs. Most are standardized, however there are some proprietary codecs that are used by different customer environments. Latency. Latency can be introduced by many different components. There's latency due to delay, just getting the data serialized on the wire. There's buffering. Due to distance is tough. Also, number of hops, the ability to read a packet, store it, forward it onto another link can be a nightmare when it comes to management. Jitter and jitter buffer different time and different order. The variability by which packets can be serialized and put out across the network really can affect the call quality of our end users. Packet loss, collisions, errors, UDP. Anytime there's a physical issue that can be impacting the forwarding of UDP packets. Not only that, but keep in mind, UDP traffic is connectionless. So when something's dropped, there's really no way to know or go back and revisit that in real-time communications such as voice over IP. Network burst and bandwidth issues. So any kind of traffic contention or high utilization of network utilizations can cause significant variability and delay in how packets are being traversed across the infrastructure, as well as class of service, quality of service misclassifications. A lot of our customers have used our solutions to kind of take a moment and audit those configurations by which were implemented to support better voice over IP service, and found that maybe other applications have fallen into that queue, or that queue was misallocated as far as the amount of bandwidth or the priority it was given. So as you can see, we've got 6 different items in here that are key factors affecting voice over IP. Now, let's take this into consideration as far as your environment as an end user, right? All of these customer networks are different. Different levels of bandwidth, different levels of budget, and then different as far as how many data centers or remote sites you have, or regional data centers there are. The connectivity of being across the internet, VPN, perhaps through a network cloud into a core data center. You have MPLS trunks, SIP trunks, private WANs, and then you have different variable bandwidths, right? T1s, multi-link T1s, 1 gig. All of these create opportunities for packets to be delivered in different order across multiple hops. It can really affect the manner by which and the speed of communications through these differing network topologies. And that creates issues where voice over IP can perform differently. We can end up with warbly sounds through the communications as a caller reaches a callee as a result of jitter or packet loss. So the key to understanding and troubleshooting voice over IP is time synchronized performance of management data, right? Is my network highly utilized? If so, who's utilizing it? Is my network healthy? Are my key links performing properly as far as a layer 1 technology aspect? Which of my sites is having the worst voice over IP? And does that correlate with application degradations? There are solutions that exist to monitor voice over IP. In fact, most of the VoIP vendors offer some level of value-added reporting. However, we have the ability to take that deeper and compare it with applications and traffic analysis. Also, we do that in a single UI that uses time-correlated reporting. So this allows us to create simple workflows where you can see how applications and voice over IP are behaving as they traverse the same infrastructure. The other thing that's important to bring up is that most IT staff is siloed and specialized. You'll have a voice over IP team, data security team, network infrastructure team, your applications team. What we have created is this single UI approach where everybody's using the same tool set, and that has really improved the collaboration of teams within those customer environments that we serve. So Some of those issues of VoIP that we talked about before. Is the class of service properly tagged? Are other applications in the VoIP queue? Is there enough bandwidth to serve this service on both ends? Also, is voice over IP impacting applications? Keep in mind, voice over IP is not connection oriented. There's no knowledge or mechanism by which it can adjust how it's communicating with the infrastructure. So I've actually seen customer environments where they've added 200 new users at a site, not realizing how much UDP traffic that was going to throw out the network, which created a scenario of traffic contention by which all TCP applications are going to run into low traffic rate availability and start to actually throttle back, right? So they're going to reduce windows, they're going to start communications over again. So they ran into not just VoIP issues, but all their key applications for that site may have started performing poorly. Also, is the IP PBX configured correctly? Multiple call managers in play could cause issues. Attaching to the most appropriate services for presence, overload and capacity issues on the IP PBX server. And also, are the proper codecs being utilized? Being able to look at different compression algorithms and how that affects the end user's call performance, we can do quite easily. So voice over IP. The VoIP data is collected via span port prior to the call system manager within the voice call center or data center. We can actually do this in multiple models where we're looking at from the edge or from the core, and this data can be augmented with that data center traffic as well as further analysis of applications. And then combining with TrueView for remote monitoring hardware probes allows for real-time analysis, proactive events and notifications, and end-to-end visibility for quicker time to identify and resolve VoIP issues. So the workflow is, 1, voice over IP proactive remote events. Let me know when a site is performing poorly. Provide me with the voice over IP network overview. Where do I have the worst stream quality and why? Let me look at that and start to do some traffic analysis. VoIP site overview, right? That's where I can drill into what is going on to that specific site. All voice over IP calls for a site, single voice over IP call at a site. Let me compare those. Is there a difference in performance from the one person that I'm speaking with versus the norm for that site? And then if there's an issue that's truly localized to a single user, let me be able to put that into a trace file of a VoIP call and perhaps play that back so I can witness that in real time as if I was actually on that call and compare it to other calls from that site. So as you know, real-time events, we have the ability to provide all kinds of real-time events around port throughput, utilization, IP class of service utilization, average VoIP LQ MOS scores, concurrent VoIP calls, new VoIP calls. Really, the ability to alert on multiple variables is well fleshed out within the solution. So an any-to-any UDP call can go wrong in many places. We want to be able to show where and why by correlating that proactive real-time event with data such as traffic analysis, application performance, etc. Here's an example of one of our stream quality views, our network overview within VoIP performance. And this gives you good, acceptable, poor performance metrics around each individual site. And as you drill into these sites down at the bottom, you'll notice that there's good, acceptable, poor, and failed metrics. There's going to be additional detail providing directionality. Is it just on the way back on that last hop that I'm performing some sort of communication that's impacted by latency? Then, and here's an example of drilling into that and being able to see the directionality. In this case, the traffic going to VoIP site B from VoIP site A is where the poor streams are being impacted, and I can continue to zero in on that to the point where I can see the phone calls that were affected by that. Not only that, I can see those calls in a way that allows me to see the class of service that they're associated with, the phone number, the IP address, both on a local and remote basis. So I can see both ends of that communication. And all of these are sortable. I can sort by duration, time, LQ MOS score at the far right-hand side, giving me my worst of kind of metrics. And in this case, I've got hundreds of calls that match my filter. Again, I can adjust this filter however necessary to further troubleshoot. Once I've derived a call that I know is performing pretty badly, I can pull up single call details. In this case, I can actually see the LQ MOS score is substantially low. I can see the codecs, the class of service, packets, network packets lost, you can see the packet loss percentage is 38%. So we've actually got a significant reduction in the ability to just transport those packets across the network. In this case, I can further export those packets and pull out a bounce diagram where I can actually look at the call setup, right? I can further analyze this and look in payload and actually look at, oh, RTP packet does not travel past the cloud. Well, that's a significant issue in call conversation. And then beyond that, I can pull back those packets and actually do a voice over IP or video playback. And in this case, select an audio flow, click on the play button, and boom, I'm provided with the actual communications. Now, obviously, with our customer base and the expectations of the market, we have the necessary permissions to ensure that you only have access to that which is configured by the administrator. So we understand in certain environments, you're not going to want to provide playback capabilities to all the users, and that can be adjusted for within the administration of the solution. Here we can play video flow, etc. So some of the key things that we want to focus on and we're able to help our customers do is, mean time to resolution, being able to troubleshoot VoIP more effectively. So being able to do per call, hop by hop analysis between two specific users, worst performing sites with a drill into clear site analyzers. So I can actually do a packet level replay, or in that case, look at an actual packet that didn't make it past a specific segment in my network. We also want to mitigate the risk of engineering changes with insight into class of service quality of service efforts. So whether you want to audit those queues, change those queues, make a change and see the effects, what we really like to do is get in early where, in a pre-deployment assessment and then post-deployment management, we can say, okay, I've made these engineering changes. This is how it affected my deployment. Audit to see if applications are in the wrong queue. Provide voice over IP traffic analysis. So how is my voice over IP playing with my key applications as they traverse the network? And also provide SIP and decode, several simple steps that follow an in-depth workflow. Now, again, I talked about those permissions. We do have the ability to provide, PCI compliance, but also voice over IP security compliance. Time correlated views with VoIP, competing traffic, impact to other applications. We have a single UI that allows you to do this on a site level basis to compare traffic analysis, end user response time of applications and individual transactions, as well as voice over IP and unified communications. Again, UDP is connectionless and unaware of network contentions. So there are cases where they don't play well with standard TCP applications. And applications on TCP, they have to throttle down in the presence of too much contention. By design, that's how it's designed to work. So awareness and customers in every type of organization. We use this same visibility to support carrier market customers, MSP, enterprise, even remote call center workforces. So with that, I do want to thank you for your time. If you have any questions, feel free to contact us for additional information. Feel free to shoot me an email directly at david.oliver@visualnetworksystems.com, and I'll be happy to answer any further questions. Again, thanks for your time and have a great day.